Hello there. Welcome to Mathematics Alive, Strategies in Problem Solving, Part 1. Today, I will be discussing Polya's problem-solving process. George Polya was a mathematician famous for his lifelong interest in the study of the process of problem solving. His name has become synonymous with problem solving. He was a Hungarian mathematician, a professor of mathematics at Stanford University, and he was noted for his work in heuristics and math education. And he is hailed as the father of modern problem solving. Polya defined intelligence as the ability to solve problems and believed that problem solving is human nature itself. To Polya, the major goal of education should be the development of problem-solving skills. In this lesson, we will study the different strategies in problem-solving and apply Polya's general problem-solving process. First, understand the problem. What are given and what are required? Second, adopt a plan. What strategy or strategies should you use? Third, carry out the plan. Solve the required value. And then, number 4, examine your solution or reflection. Look back at the problem and check if your answer satisfies the conditions in the problem. And my personal acronym for this process is GRACE. G-R-A-C-E. Remember, you need GRACE to solve a problem. G stands for given, R stands for required, and A stands for adopt a plan, and C stands for carry out the plan, and E stands for examine your solution or reflect. Here are some problem-solving strategies. Draw a diagram or a picture, make a list, guess and check, look for a pattern, make a table, use a formula, solve backwards. Use a variable, use multiple strategies, use your imagination or common sense, solve a simpler problem. Use manipulatives, use logical reasoning, make a model, simulate the problem, make an equation, and you can add some more to this list. The choice of a problem-solving strategy suggests the first step and helps the problem solver to see the next step. Good problem solvers do not give up. If the first strategy does not work, they try a different strategy. That's why we have trial and error method. Here are some sample problems. Number 1, dividing the land. A father of 4 children owns an L-shaped tract of land consisting of 3 adjacent square lots. In his last will and testament, he has to divide the land into 4 equal lots, all similar in shape, for his 4 children. Help this man divide the land. Here are the strategies that we can use. Draw a figure and use trial and error. You can draw several figures which represent the L-shaped tract of land, and then you can try the different figures which will fit the requirement of the problem. The land is to be divided into 4 equal lots, and these lots are all similar in shape. So the usual strategy is to divide the land like letter A. But if you look at the figure, the shape of the lots are not equal and they are not similar as well. So some people give this letter B as a suggestion. And if you look at the lots, they are all triangular, they are all similar, but they are not equal in area. So it will not be fair for the other siblings if one gets a smaller area and the other gets a bigger area. So we can try another one. Okay, letter C. So if we look at letter C, all lots will be L-shaped and they have the same area. So letter C fits the requirement of the problem, and letter C is our answer. Number 2, divide the face of the clock into 3 parts with 2 line segments so that the sum of the numbers in each part is equal. Strategy, trial and error, and then draw the figure. So we have a drawing of the face of the clock, and the first step is to add all the numbers in the face of the clock and divide the sum by 3. So we have 78 divided by 3 is equal to 26. So the sum of each part of the division of the clock should be 26. So by trial and error, we have arrived at this answer. And if we add the numbers in this part, we have 11 plus 12 plus 1 plus 2 equals 26. And then in this part, we have 10 plus 9 plus 4 plus 3 is equal to 26. And then in this part, we also have 26. So we have satisfied the requirement of the problem. Number 3, flip the triangle in 3 moves such that the triangle will be inverted. So the strategy here is to use manipulatives, use coins, and then also you use trial and error method. And the answer is you move the coin here to this direction, or you can also move it to the other position in this direction. It depends on you. But we have just flipped the triangle or inverted the position of the triangle by just taking 3 moves. Number 4, who plays what? Of 5 players in a basketball team, 2 are guards, 2 are forward, and 1 is center. Jimmy, Kobe, and Luke play on a team. 1 plays center, 1 plays forward, and 1 plays guard. If Kobe and the center each scored more than Luke, and Kobe is not forward, find out who plays what position. So the strategy here is elimination method and using a table. So first, we cross or check the box that corresponds to the player position. The condition is Kobe and the center each scored more than Luke, and Kobe is not forward. So we look at the line representing Kobe. Kobe should not be the center because Kobe and the center each scored more than Luke. And Kobe is not forward, so we put an X on the column for center and put an X for the column for forward. And the only choice is that Kobe should be the guard. And also, Luke scored more than the center. So, Luke cannot be the center, so you put an X here, and therefore, the only choice is that Jimmy is the center. So, we have Jimmy here, and so Jimmy is not forward, you put an X here, and Jimmy is not guard, put an X here. Kobe is already a guard, and so Luke is what? Luke cannot be the guard, so we put another X under the guard, so Luke is forward. Problem number 5. There are 15 people in a room. 8 people are wearing socks, represented by set A. 7 people are wearing shoes, represented by set B. And 5 are wearing both. How many are barefooted? Strategy. Draw a Venn diagram to show the relationships between the different groups. So we have here the 5 people who are wearing both. It will be represented by the intersection of the two sets. And then since 8 people are wearing socks, we represent that with the 3 people, which is the difference between 8 and 5. So to add 5 and 3, we have a total of 8 people for set A. And then we have 7 people are wearing shoes, represented by set B. So we have already 5 in the intersection, and we have to put 2 in this portion of set B. So 5 plus 2 is equal to 7. And if we add this 3 numbers, we have 10. So since there are 15 people in the room, what is left for those who are not wearing socks or shoes, or those who are barefooted, is equal to 15 minus 10 is equal to 5. So 5 people are barefooted. Number 6, handshake problems. There are 20 guests and 1 host in a party. If each one is to shake hands with each other, how many handshakes will there be? How many handshakes will there be for n number of people, or any number of people? Strategies: we have make a simpler problem, make a mathematical model, and make a table, find a pattern, and find a formula, or look for a formula. First, we make a mathematical model and represent 1 point as 1 person, and 1 segment is equal to 1 handshake. So if we have 2 points here, connect these 2 points by 1 segment, you have 2 people is equal to 1 handshake. Of course, if there is only 1 person, there is no handshake. And if the next person comes along, we have 3 people, so we will add another 2 handshakes. So if there are 3 people, you have 3 segments or 3 handshakes. And then if the next people comes along, or next person comes along, we have additional of 3 handshakes again. So, and if the 5th person comes along, we have an additional of 1, 2, 3, 4 handshakes. So we'll put this on a table and observe a pattern. So here, 1 person, 0 handshake. 2 persons, 1 handshake. 3 persons, you have 1 plus 2. 4 persons, you have 1 plus 2 plus 3. So you have 6 handshakes. And if you have 5 persons, you have 1 plus 2 plus 3 plus 4, or 10 handshakes. And if we observe the pattern, if we have n persons, then the last number here will be n minus 1. Because if we have 5 persons, the last number in the series is 4, or 5 minus 1. So if we have n, the last number here will be n minus 1. And the formula for this sum is equal to n times n minus 1 over 2. So if we have 21 persons in the room, then we have 1 plus 2 plus 3 plus 4 plus 21 minus 1 number of handshakes. In the formula, we have number of handshakes is equal to 21 times 20 divided by 2 is equal to 210. How many handshakes will there be if there are 30 people? Solution: n is equal to 30, and so the number of handshakes is equal to n times n minus 1 plus or divided by 2. So the number of handshakes equal to 30 times 29 divided by 2 is equal to 435 handshakes. I hope the problem-solving strategies discussed in this lesson will be of help to you in your daily problem solving. In my next video, I will be discussing solving problems in geometry using familiar formulas. Welcome to the Problem Solvers Club. Please don't forget to like, share, and subscribe to this channel by clicking the button below. Thanks for watching and bye-bye!